Raj and I'm HD1 at Nagar right now, and today we will be covering the topics of data structures and algorithms, and what is data structures and what is algorithms and what is the application of data structure and what is an algorithm and what types of algorithm which we are going to study in this on this channel. Okay, so let's start now. So topic name is first is data structures and algorithm. So there's two different terms here, data structures. Okay, first one is data structures, okay, data structures, and second one is algorithm, and in short we did it DSA, that means data structures and algorithm. Okay, so data structure, it refers to a fundamental concept in computer science and programming that focus on the organizations and manipulations of data and algorithm used to perform operation on that data. Means basically in data structures, basically we study over the data only, because for any company, for anything, data is much more important. Okay, because in always we talk about data only. For data, to retrieve the data, we write an algorithm that should be take less time. Like you suppose you write algorithm A1 and you write algorithm A2, right, to access this data, right? So this one is taking 1 millisecond, but this one is taking 2 millisecond, right? So which one is best? Obviously this A1 algorithm is best. So basically we design an algorithm for retrieving the data. Okay, so that means this lines. Okay, now move on the second point, data structures. What is data structures? Okay, suppose you are having the set of data like D1s, D2, D3 and Dn. Okay, so you have to retrieve this data. That should take the suppose you arrange the data in that way, while retrieving this data, the time should be less. Okay, time should be less. So we just find the way where we can store this data that should be taken the less time, okay, as compared to the other organizations. Now data structures are used to store and organize data efficiently. Okay, and while algorithms are step-by-step procedure designed to solve a specific problems and perform a specific tasks, right? What does it mean? That I'll explain you in later. Okay, don't worry about that. So basically data structure means that we store the data in that format, in that way, while thereby we should take the less time to retrieve those data. Okay, but simple, like just it should take like just 0.2 milliseconds and like this. Okay, now some of the application of data structures, that means where we can use our data structures in real life scenario. Okay, where we can use it. Okay, so application means problems, okay, of DSA. So first one is your software development. DSA from the backbones of the software development. Okay, helping programmers efficiently store and retrieve manipulate data. So basically whenever we talk about the data structures, we generally talk about data only, like just data. Okay, just data. Now fine, we can also use in our web development scenario. We can also use in the game development. You can read this lines that is mentioned here. Okay, and also we can use in most important database management, DBMS. Okay, we can use here also DBMS, database management system. Okay, so indexing, hashing and storing the algorithm that are used to enhance database performance, right? And also we can use in networking and routing. Also we can use in artificial intelligence and machine learning, right? And also we can use the cryptography and security and compiler design as well. Okay, and operating systems and embedded systems. So we can use our data structure in the many scenario, in the many different applications in real life examples. Okay, in real life example. Also robotics, we can use data structures. Just data structure means that suppose you like you are having data D1 to Dn, right? So you just arrange the data in that way. Like suppose you are in data D1 and then Dn, like, so while retrieving this data, it should take less time. Okay, basically it should take less time. Okay, so for this we design an algorithm. Okay, algorithm that should take the less time, right? We will understand deeply while solving the real life problems. Okay, so don't worry about that. Just stick with this video and keep watching our video on these channels, and do like and subscribe. Okay, now let's understand some important topic which we are going to cover on this channels. Okay, so some of the main topics that will be covered. Okay, that will be covered within DSA, data structures and algorithms. Okay, topics we will covering here, and some main topic that is here. Okay, so data, that is data. We just data, and that after a structures. We just structure the data in that way that should take the less time while retrieving this data. Okay, the simple and crystal meaning, right? Now fine. Array. Okay, array. If I talk about array is the most important data structures. Okay, array, this is the linear data structure, this is the linear DS data structures, right? Linked list is also linear data structures. Linked list is also most important. In linked list, single linked list, double linked list, and circular linked list. Okay, and arrays also. So what is array? Array is like some simple, it is a continuous block of memory of same data types, basically. If you are putting here integer, then in all the box there will be integer. If you are putting here character, so in all the boxes will be characters only. Okay, that means of the same data types, and it is contiguous. It is a contiguous block of memory. Okay, just simple. And linked list, it is linked list. What is linked list? So linked list basically nothing. Linked list is just nothing. I can say that what is linked list? So linked list is just your collection of collections of nodes. What does it mean? Suppose a node, there is a node. Okay, a node can have data in this box data. Okay, and in this the address of another node that will connect to the other node. Okay, like this ones. So linked list is a collection of node only. Okay, we define linked list node using OOPS, object oriented programming, and also we will making the video on the OOPS as well, so don't worry about that. Okay, and a stack also is a linear data structures. Okay, and a stack, it is just for the retrieving the data, and in big of one time complexity, a stack. So stack is also known as last in first output, that is called LIFO. Last in first output. Suppose there is a stack, so on the top will be the last element, and first this element will be pop from the stack. Okay, and we can perform the operation on the stack, push, pop, and empty. Okay, and size of the stack also. Queue is a similar linear data structures. Okay, and and also stack we use in the DFS traversals technique. Okay, and queue that we used in BFS traversal, and it is called FIFO, first in first output. Means basically, suppose you are having your queue here. Okay, so whatever the element will be the first, that will pop first. Okay, in queue, that is called FIFO, first in first output, right? And in tree, basically most important data structure, and many popular company like MNC and PVC company, this on the tree based question is being asked. Okay, tree, like your binary tree, I can say about your binary tree. Okay, binary search tree, a whale tree, red black tree, and B tree. So what are these topics we will covering on this channel, so don't worry about that. We are just giving the overview of the data structures, like what type of data structures. And heap is the most important data structures. Okay, like in heap there are two types of heap, mean heap and max heap. That's most important, and basically we use heap in on the array questions basically. Okay, so heap is most important data structures, we will covering with the example as well. And hashing is the most important. In heap, the time complexity for all the operations big of log n's. Okay, and hashing is just like a hashing. For the hashing, like for the insert, delete, and find an element, so it will take all the big of n. That means constant time complexity. So hashing is also most important data structures. Hashing, okay, most important. Okay. And now graph is an advanced topic of data structures. We will cover in the graph also. What is graph? So graph is a collection of also node. In graph basically we talk about the connected component and disconnected component, and forestry and all that. Okay, and a cyclic graph on a cyclic graph. Okay, so it is a directed graph, undirected graph, weighted graph, and unweighted graph. Okay, so what does this, I will explaining in this video, so don't worry about that. And hash tables like just the simple like a hashing. Okay, and we'll copy try is try and segment tree. Okay, try and segment tree, DSU, disjoint union set. Okay, and your fanfic tree. Okay, so these are the advanced data structures that we will be covering in this channel, so don't worry about it. Okay, and that's simple. So here is the patterns that for your understanding that. Okay, so what is like sorting algorithm. So sorting algorithm, like you are having your there are the various types of sorting algorithm. I will taking the name like few of them, like bubble sort. Okay, selection sort, insertion sort, and queue sort, merge sort, counting sort, many more sorting, heap sort. Okay, many more. So we will covering that V sorting is stable and unstable. V sorting is out place and out in place sorting algorithm. So don't worry about that. We will covering also these topics in this video, because in an interview this question would be asked. Okay, What is linked list? Already I discussed. It is collection of node. List is it like a DQ? Okay, you can you can push and pop the element from the both side. Okay, like from the front and back end as well. Okay, and the spanning tree, like just basically tree about it, and tree also like tree. This is the node. This is the root node, and this node is having the children this and this. Okay, and this node is having this and this. This is the leaf node. Okay, leaf node, and this is the edges. Okay, and the graph. This is the connected component. Okay, and it's the stack and hashing. Like you can perform the every operation in hashing big of one, and the stack also big of one, and graph is like the connected component, disconnected component. Okay, sorting as well there. Okay, so and now we'll talk about the algorithm. What is algorithm? Suppose you are having the problem P1. Okay, you are having the problem P1, and somebody told you that you have to write an algorithm. You have to write an algorithm that should take big O of one time complexity. It should take the 0.1 millisecond. Okay, so you have to write this. You have to write an algorithm for this problem P1. Okay, so that is the algorithm. Means basically we design a patterns of we design an algorithm. Okay, an algorithm. So what does it mean? So design algorithm to retrieve with the database. Basically, what does it mean that an algorithm? Basically, we use an algorithm to retrieve with the data. Okay, that should take the constant time, yeah, less time, like 0.1 millisecond, yeah, 0.00 millisecond, like something this. Okay, so this one is the problem P1. We have to design an algorithm, and your algorithm must be terminated after getting your answer. Like you suppose you write an algorithm and your algorithm keep running and keep running. That is not right algorithm. Your algorithm should be deterministic and it should terminate after some times. Okay, after getting your desired output. Okay, so that means what is algorithm? Algorithm basically means we design an algorithm that should take the less time to retrieve with the database, yeah, data. Okay, that means algorithm. You can also here give the input here and give the output, set up the rules to obtain the accepted output from the given input. Okay, this meaning is an algorithm, right? So types of algorithm which will be covering all these channels, and that these algorithms are very famous. So your first one is a searching algorithms. Searching that will take big O in time complexity. Okay, linear search and binary search. Okay, binary search like it will take big O of 1 in the best case. Okay, and the worst case it will take big O of log n. Okay, that's very important question also is asked in the interview. Linear search will basically be applying on the array, and binary also apply on the array. Okay, and also I will teach you the STL library. That will the very inbuilt function that you don't have to write a long number of line of code. Okay, within the one line you will get the answer, right? Okay, so now sorting algorithm, that is bubble sort, selection sort, insertion sort, and merge sort, and keep sort, and heap sort. So heap sort and keep sort and merge sort, these sorting are very famous and that are asked in an interview. Okay, recursion and backtracking. Recursion, what is recursion? I will tell you. Recursion basically what we'll understand about the recursion, the function which call itself. It's a very old definition of recursion, but recursion basically means that which recursion help us to solve the bigger problem. We just give the small path of the to the recursion, and recursion solve our bigger problem and give the output. Okay, that is the meaning of recursions, right? And also it is called the function which call itself, that is called recursion. And the backtracking, without recursion you cannot implement backtracking. So backtracking is also important. What is backtracking? Backtracking just be exploring all the part and exploring the data, and after exploring all the part we get the best data what is suitable for our output and our questions. Okay, so backtracking basically we explore all the path and get our answer, right? So what is backtracking? Also we will be making the video on like the question n queues, visual n queues, Sudoku solvers, combination of letter combination of the phone number, and many questions that will in the backtracking, and also your permutation of strings. Okay, and greedy algorithm. So greedy algorithm is most important, and there is also difference what dynamic programming and greedy algorithm, which one is best. So I always prefer to say that dynamic programming is always best rather than greedy can fail sometimes. Okay, but dynamic programming can never be fail. Okay, so dynamic programming is the most important algorithm that you should remembering all that. So we will be making the video on dynamic programming as well, so don't worry about it, and greedy as well. Okay, now divide and conquer, that is the best that is a very important algorithm. Basically in dynamic programming what we do, we suppose we are having the problem P1 and B is split in the smaller problem like P2 and P3, like similar kind of approach fundamentally applies. Just suppose you are binary search BS, so whenever you are just dividing the array in the small piece, the same you are applying the same concept on the binary search. We keep applying until it reaches to the single box of the element, right? So divide and conquer is like dividing the bigger problem into smaller parts, right? Simple. The graph algorithm like BFS and DFS versions. Okay, we will covering also video on that. So this is very famous algorithms: Dijkstra, Bellman-Ford algorithms, and Crucial algorithms, and Prim's algorithms, right? Okay, so now string algorithms like pattern matching, longest common subsequence, that is called LCA. That's a very famous questions. Okay, and pattern matching, that is based on the two-pointer approach. Okay, And bit manipulation is one of the most important technique that will that should be used in your coding journey and coding life. It's very important, but very important topic, bit manipulations. Okay, like here you will XOR operator and operator and OR operator. That's the simple best question on come on that. Number theory algorithm like GCD, you will find GCD to number, LCM, prime number generations, and like also you find the prime number in big of root n. Yeah, you can find the prime number in log n. Okay, so find out this algorithm, like we will find a sieve algorithm also using to find the prime numbers. Okay, and hashing algorithm, I already told you, we will do big O phone time complexity for all the operations, insert, delete and find. Okay, and fine. So I can say that functions and collisions resolutions as well. Okay, so guys, we will almost be covered our all the topics of data structures and algorithm. Now you can observe, and we will give the link of this PPT. Okay, so you can refer to understand what is this. Okay, so don't worry about that, and we will, and also one more topic which I would like to cover here. Okay, that is your time complexity. We will be making the separate video of the time TC and AC. Okay, time complexity or a space complexity, so don't worry about that. Okay, what is it and what is, this is very important for, because in interview, okay, in interview basically interviewer will talk about only time complexity or a space complexity, like suppose your big of 1, yeah, big of n. Okay, that's it. So time and space complexity. Big O notation means time complexity notation in like there are three notations, like big O one notations we can write. Yeah, you can write omega, this one, yeah, theta one. Basically you can write in any of these notations. There's no any restriction that big O omega is best, big O theta is best, and big omega is best. Or to writing the time in these three notations is similar. Meaning is same to all of these have. Okay, and the best and average and worst time complexity. I will talk about the best and average. So I can talk about the yeah, let's say for example like the binary search. Okay, in best case it will be big of n, and in average in log n. Okay, and worst also in log n. Simple meaning. Okay, you cannot say that ki omega 1 is like best and big of 1 n is worst. Not like this is nothing like that. You can write the time complexity in any notations like theta, omega, and big O. So basically people will prefer to write in big O. Okay, that's simple. And advanced topic we will cover here on this channel. So, graph algorithm, topological sorting, so strongly connected component and network flow. Okay, advanced data structures, segment tree, family tree, and disjoint union set, and approximation algorithms, and NB completeness and computational complexity theories. Okay, so we will covering these on this channel. So guys, don't worry about that, and thank you so much to watch this video till then, and please do hit the like on this video, because it gives us motivations, and please do subscribe these channels. Okay, to never forget the never miss the latest video which we are going to upload on this channel of data structures and algorithms. Okay, and please do share with your friend this video, and who is preparing for the placement and internship and all that. Okay, and thank you so much. Until then, keep practicing and keep exploring yourself.